Namaskar, welcome to Exercise Explained. In this video, we would be doing exercise 2C of motion in one dimension, ICSE 9th. I would be solving from question number 1 till question number 6 in this particular video. The rest of the questions will be done in separate videos, the link for which will be given in the description below. So let us start with the first question. A body starts from rest with a uniform acceleration of 2 meter per second square. Find the distance covered by the body in 2 seconds. So here it is given clearly that it starts from rest. The body starts from rest. So when it is given the body starts from rest, we should understand that initial velocity is equal to 0. Acceleration value is given as 2 meter per second square. Time is given as 2 seconds. Displacement we need to find. So since this is the first video of 9th standard, I would be explaining you how to choose an equation. So for that, I would be writing all the three equations here, the three equations of motion. The first one is velocity time relation, that is v is equal to u plus at. The next one is position time relation, so that is s is equal to ut plus half at square. And the third one is position velocity relation, that is v square is equal to u square plus 2as. Now the biggest doubt comes in selecting which equation we should use out of these three. Now the clue here is whichever will have a single unknown, we will be choosing that. So let us see the given data. U is there. So let us compare with the first equation, that is v is equal to u plus at. So in this, u is there in the given data, a is there in the given data, t is there in the given data. Final velocity we can find from this equation, since all these three are there and there is only one unknown. But did the question ask us to find final velocity? No, the question did not ask us to find final velocity. So what we would do is we would not be using this equation. Now the question has asked to find displacement. Now these are the two equations which have displacement. So let us compare this. So S we need to find, so there is one unknown quantity. U is given in the equation here. T is there in the question. A is there in the question. T is again there in the question. So we can definitely use this to find the value of S. So v square is equal to u square plus 2as. Now in this equation you can see v is not there in the given data and s is also not there in the given data. So here we have two unknowns. So when we have two unknowns, we cannot solve this. So this is also not possible. So the only option here is s is equal to ut plus half at square, and I'll be proceeding ahead with that. So s is equal to ut plus half at square. So that gives me 0 into t, because u is 0, t is 2. So 0 into 2 plus half into a is 2 into t square is 2 square. So I get it as 0 plus 4, that gives me 4 meter. So this is the way we actually decide which equation to use. Coming to the next question, that is question number 2, exercise 2C. A body starts with initial velocity of 10 meter per second and acceleration 5 meter per second square. Find the distance covered by it in 5 seconds. So initial velocity is given as 10 meter per second. Acceleration is given as 5 meter per second square. Distance is given as distance we need to find, and time is given as 5 seconds. So I just wrote the given data. U is 10 meter per second, A is 5 meter per second square, T is 5 seconds, S we need to find. So now we would see these three equations here. Since we have to find s, the first equation does not have s at all, so this is definitely rejected. Coming to the next one, s is equal to ut plus half at square. You can see u is there here, t is also there, a is also there, so we can use the second equation again. So I would be using the second equation, that is s is equal to ut plus half at square. So that gives me 10 into 5, that is u into t is 10 into 5 plus half into a is 5 into t square is 5 into 5. So we get it as 50 plus here 5 into 5 is 25 into 5 is 125, so 125 by 2. So here we get it as 50 plus 72.5, so that gives me 112.5 meters. So the distance covered by it in 5 seconds is 112.5 meters. Coming to question number 3, a vehicle is accelerating on a straight road. Its velocity at any instant is 30 km per hour. After 2 seconds, it is 33.6 kilometers per hour, and after further 2 seconds, it is 37.2 kilometers per hour. Find the acceleration of the vehicle in meter per second square. And the question has asked, is the acceleration uniform? So what I do is I convert all the three values to meter per second. So V1 I take it as 30 kilometers per hour. So that gives me 30 into 5 by 18. So that gives me 8.33 meter per second. Now T1 is 2 seconds. Now after 2 seconds what happens? It reaches a speed of 33.6 kilometers per hour. So 33.6 kilometers per hour I convert it to meter per second. So I multiply by 5 by 18. Kilometer per hour whenever converting to meter per second will be multiplied by 5 by 18. So 33.6 into 5 by 18 gives me 9.33 meter per second. T2 is given as again 2 seconds, and V3, that is the velocity, is 37.2 kilometer per hour. Being converted to meter per second, we get it as 10.33 meter per second. Now we would be finding acceleration for each case. So for the first acceleration, we would be finding v2 minus v1 divided by the time taken, so t1. So I write that v2 minus v1 divided by t1. v2 happens to be 9.33, v1 happens to be minus 8.33 divided by 2. So that gives me 1 divided by 2, because 9.33 minus 8.33 gives me 1 by 2, that is 0.5 meter per second square. Now I would be finding the next acceleration, that would be v3 minus v2 divided by t2. So v3 was 10.33 minus 9.33 divided by 2. So here again I get it as 1 divided by 2. Again I get it as 0.5 meter per second square. Now, since we can see that the acceleration for the first case is equal to the acceleration for the second case, we can say that it is uniform acceleration. Now, we need to find the total acceleration of the body. So, for finding total acceleration, what we do is a is equal to v3 minus v1. That means the last final velocity minus the initial velocity divided by total time taken. Now total time happens to be t1 plus t2. So we get 10.33 minus 8.33 divided by 2 plus 2. So 2 plus 2 happens to be 4, and 10.33 minus 8.33 happens to be 2. So we get 2 by 4, that is nothing but 0.5 meter per second square. So the total acceleration is also 0.5 meter per second square, and the acceleration for the first part is also 0.5 meter per second square. Acceleration for the second part is also 0.5 meter per second square. So definitely this is a case of uniform acceleration. Now coming to the next question, that is question number 4. A body initially at rest. So initially at rest means initial velocity will be equal to 0. Starts moving with a constant acceleration of 2 meter per second square. So A is given as 2 meter per second square. Calculate the velocity acquired. So that means the final velocity we need to find. Distance traveled in 5 seconds. So that means we need to find S. So I write down U is equal to 0. A is equal to 2 meter per second square, and time I take this as 5 seconds. So for finding final velocity, we can use V is equal to U plus AT. U happens to be 0, A happens to be 2, and T happens to be 5. So we get 0 plus 2 into 5. That is nothing but 10 meter per second. So the final velocity reached, or the velocity acquired, is 10 meter per second. Now we need to find the distance traveled. So for that, I would be using S is equal to UT plus half AT square. So I just substitute the values. U is 0 into T is 5 plus half into A is 2 into T square is 5 square. 2 and 2 cancels. 5 square is 25. So we get the distance traveled in 5 seconds as 25 meters. Now getting to the fifth question. So that is a bullet initially moving with a velocity of 20 meter per second. So initial velocity is 20 meter per second. Strikes a target and comes to rest. That means final velocity is 0 after penetrating a distance of 10 centimeters. So that means the distance, that is S, or displacement, is 10 centimeter. Calculate the retardation caused by the target. So we will be using acceleration formula for this. So let us understand that we have a block like this here. The bullet comes, hits the block, goes inside by 10 centimeter, and then comes to rest. So I just write the given data. That happens to be S is equal to 10 centimeter. So I have to convert this to meter since this is not there in SI unit. So 10 divided by 100 gives me 0.1 meter. Initial velocity is 20 meter per second. Final velocity, since the bullet stops, is 0. So I use 2as is equal to v square minus u square. So S will be equal to v square minus u square, or A will be equal to v square minus u square divided by 2s. So I would be using this formula since I need to find acceleration. So acceleration will be v square happens to be 0 square minus u square happens to be 20 square divided by 2s happens to be 2 into 0.1. So that happens to be minus 400 divided by 0.2. I multiply numerator and denominator by 10. I get minus 4000 by 2. That is nothing but minus 2000 meter per second square. So this is the acceleration. Now coming to the retardation happens to be 2000 meter per second square. Hope you guys have liked the video. Do share it with your friends and consider subscribing to the channel. Question number 6 onwards will be there in the next video. Dhanyavad.